Absolute value is a fundamental mathematical concept used to measure the distance of a real number from zero, regardless of its sign. In this lesson, we'll explore the definition of absolute value, its algebraic properties, and the absolute value function, and delve into graphing absolute value functions. The absolute value of a real number x, denoted in this way, is defined as follows. The absolute value of x is equal to x if x is greater than or equal to 0, and negative x if x is less than 0. Sometimes we see the absolute value defined as the absolute value of x equals the square root of x squared. Here are some examples. The absolute value of negative 3 equals 3, and the absolute value of 5 equals 5. Y equals the absolute value of x is called the absolute value function. And here is its graph. Let's say a equals 2, b equals negative 5, and c equals negative 7. Find the absolute value of a minus the absolute value of b. This is the absolute value of 2 minus the absolute value of negative 5. The absolute value of 2 is 2, and the absolute value of minus 5 is 5. So we have 2 minus 5, which is negative 3. Find the absolute value of a times the absolute value of c. This is the absolute value of 2 times the absolute value of minus 7, which is 2 times 7, which is 14. Find the absolute value of a times c. This is the absolute value of 2 times minus 7, which is the absolute value of minus 14, which is 14. Let's look at some graphs involving the absolute value function. That is, for a function f of x, the graph of y equals f of the absolute value of x, and the graph of y equals the absolute value of f of x. To graph y equals f of the absolute value of x from the graph of y equals f of x, we firstly discard the part of the graph where x is less than 0 and reflect the graph of x is greater than or equal to 0 in the y-axis, keeping what was there. To graph y equals the absolute value of f of x from the graph of y equals f of x, we keep the graph for f of x greater than or equal to 0 and reflect the graph in the x-axis for f of x is less than 0, discarding what was there. Let's do some examples. Draw y equals f of x equals 2x minus 3, y equals the absolute value of f of x, and y equals f of the absolute value of x. Here is the graph of y equals 2x minus 3. Now we define y equals f of the absolute value of x as f of x if x is greater than or equal to 0, and f of minus x if x is less than 0. To graph y equals f of the absolute value of x, which equals 2 times the absolute value of x minus 3, we take the graph of y equals 2x minus 3 and discard the part where x is less than 0. That's this part. Then we reflect the part where x is greater than or equal to 0 in the y-axis. So that looks like this. We define y equals the absolute value of f of x as f of x if f of x is greater than or equal to 0, and minus f of x if f of x is less than 0. To graph y equals the absolute value of f of x, which equals the absolute value of 2x minus 3, we take the graph of y equals 2x minus 3 and we reflect the part of the graph where y is less than 0 in the x-axis. Then we discard what was there. So we reflect this part in the x-axis and discard what was there. So this is the graph of the absolute value of 2x minus 3. Let's continue with some more examples. I've written some useful points to help us with these examples, which I'll keep on the screen. Sketch y equals x squared minus 4 and y equals the absolute value of x squared minus 4. First, sketch y equals x squared minus 4. That is a U-shaped graph that intersects the x-axis at -2 and 2 and the y-axis at -4. Now for y equals the absolute value of x squared minus 4. As we're taking the absolute value of the entire function, we are sketching y equals the absolute value of f of x. So we keep the graph where f of x is greater than or equal to 0 and reflect the bit where f of x is less than 0, discarding what was there on the original graph. That looks like this, with the same x-intercepts as before, but now the y-intercept is at y equals 4. Let's do another example. Sketch y equals x squared minus 2x and y equals the absolute value of x squared minus 2 times the absolute value of x. First, sketch x squared minus 2x. This graph is a U-shape that crosses through the origin and intercepts the x-axis again at x equals 2. Now, the absolute value of x squared minus 2 times the absolute value of x is a function of the absolute value of x. So we discard the part of the original graph where x is less than 0 and reflect the part where x is greater than or equal to 0 in the y-axis. So this is the part of the original graph that is greater than or equal to 0. Now we just need to reflect it in the y-axis. That looks like this. So now the graph meets the x-axis at 2, 0, and -2. Let's summarize the key points from this lesson. The absolute value of a real number x, denoted in this way, is defined as follows. The absolute value of x equals x if x is greater than or equal to 0, and minus x if x is less than 0. To graph y equals the absolute value of x, from the graph of y equals f of x, discard the part of the graph where x is less than 0, and reflect the graph of x is greater than or equal to 0 in the y-axis, keeping what was there. To graph y equals the absolute value of f of x from the graph of y equals f of x, keep the graph for f of x greater than or equal to 0 and reflect the graph in the x-axis for f of x less than 0, discarding what was there.
Hey guys, two things. If you do have any questions regarding the content we just covered, just go ahead and drop that in the comments. I'll make sure to get to that as soon as possible. And secondly, if you liked the video or if you got anything that was useful from it, make sure to check out the website, Prep Folders. There's so many more videos like this, so many more resources, practice questions and all the lot. So just go ahead and have a look. If you need help, there's some tutors and mentors there as well. So just have some fun over there. And yeah, we'll see you on the other side.